Yeah, that's really pretty much all you can say about it, right? Now, what's it like to taste an apple? Sweet. What else? Crunchy. Okay. Let's take sweet. What's sweet like? There you go. Okay. These qualia are indescribable in some fundamental sense. You kind of know it when you see it, but that's basically it. The second property that Dennett talks about is that they are intrinsic, by which he means they can't be analyzed into something more basic, like red or sweet. Yeah, there's just really nothing more you can say about something except that it's red or it's sweet. The third of these characteristics or properties is that they're private. It's the nature of qualia that you can't really make interpersonal comparisons. If I crunch into an apple and I say, oh, it's sweet, and you do the same thing, I really don't know, and I have absolutely no way of finding out whether your experience of sweet is the same as my experience of sweet. We both call that experience sweet, but I really don't know what that apple tastes like to you. That is a purely private experience. And even if you said, here, taste this apple, is that sweet? Well, I might say yes, but we still don't know whether my experience of the apple of sweetness is the same as yours. Yeah. It might be reasonable to assume, but you have no grounds for doing so. Okay? We all assume that. If I go home to my wife tonight and I'm making some dish and I say, does that taste too spicy to you? I've got to be able to rely on her judgment, right? That it's too spicy, right? But I don't know, exactly what that experience is like for her. So yes, in order to get along in the world, in order to share experiences and share language, we have to assume that we mean pretty much the same thing by each other when we use the same words. But it's not, if you think about it, it's not necessarily logically the case, okay? And I don't have time to go into this, nor do I think I have the brain power, but there's this problem of the inverted spectrum, where you can imagine now that there's an individual who, when he sees a light of a particular wavelength, sees red when everybody else sees green, but he's learned to call that red. All right? Well, okay, he calls it red, right? But he sees green, right? So it's just not, it doesn't logically follow, okay? It is an assumption of convenience that we make. And then finally, these qualia are what Dennett calls directly apprehended, which means they're not mediated by anything else. We see them directly. We don't say, oh, I think it's red, or gee, that has a particular kind of wavelength, so I'm going to call it red or anything like that. We just see these things the way they are. Now, this problem of qualia is something that's bothered philosophers and other cognitive scientists for a long time, and has set the stage for a number of interesting thought experiments, of which perhaps is the most famous is the problem of Mary, the color scientist, a problem set out by philosopher Frank Jackson. He wants us to imagine a woman named Mary, who's a visual neuroscientist, who has been raised her entire life in an achromatic chamber, a chamber where the only colors, if that's what they are various whites and blacks and grays, nothing else. Nevertheless, by virtue of attending lectures such as these, and lectures by people like Stephen Palmer and all that, she knows all there is to know about the nervous system and all there is to know about the experience of color. Now, what Putnam asks us to imagine is that at some point Mary is let out, okay, into this world of blooming, buzzing color, and what we want to know is what does she experience when she emerges from the chamber? Will she have a new experience, or by virtue of knowing everything there is to know about the nervous system, and by virtue of knowing everything there is to know about the physics of color, will she say, that the world just hasn't changed for her? Or is she going to have this? No, kidding. That's what it looks like. Okay? What exactly will happen to her when she steps into the real world? There's another version of this, also from Jackson, called Fred the Scientist with Supervision. And we're asked to imagine another person, the Fred, who's also a visual neuroscientist, and he knows everything there is to know about vision and about the nervous system and all of that. But he's one of these people who has a visual range that is beyond the normal. He can see in the infrared spectrum wavelengths greater than about 780 or 800 nanometers. And he can see in the ultraviolet spectrum as well. Very long wavelengths, very short wavelengths that are not sensible to people like us, mere mortals. Again, Putnam asks us to imagine an observer who knows all there is to know about the nervous system and then want to predict what it is exactly that Fred sees when he's stimulated with infrared or ultraviolet light. Is there anything about anything about our knowledge of the nervous system that would predict to us what his sensory experience is, what kind of quality of experience he will have? And basically, as far as these things go, Jackson and others think that Mary will have a new experience, okay, once she emerges into a world of color, that you can't simply deduce from knowledge of physical and biological facts what that experience will look like. And Putnam also thinks that we have no idea. We have no way of predicting what color Fred will experience when he's stimulated with infrared and ultraviolet light. Now, what's interesting about this is, notice the dates here, okay, 1982, 1986. There is such a person, okay? Knut Nordby is in fact a vision scientist who specializes in the problem of color vision, who is himself congenitally colorblind. From birth, he's got just no ability to see the world in anything other than a set of blacks and whites and grays. And Nordby himself seems to think that Putnam's intuition is right. Although I have acquired a thorough theoretical knowledge of the physics of colors and the physiology of the color receptor mechanisms, nobody knows more about this than Knut Nordby. Nothing of this can help me to understand the true nature of colors. And he studied the history of art, and he knows that apples are painted red, and he knows that trees are painted green, and all of that kind of stuff. He simply doesn't have any of these experiences. This, too, does not give me an understanding of the essential character or quality of colors. It's this characteristic that we mean when we say it's kind of ineffable, these kinds of qualities. Okay, so let's look a little bit. Here's another case. It's quite interesting, case that was made famous by Oliver Sacks. Patient J.I., who was a visual artist. He was a painter who, by virtue of the brain disease, got what's known as acquired color blindness. There's a particular area of the brain that is importantly involved in color perception, area V4, which is in there someplace. And that got knocked out for him so that he lost the ability to see color, okay? And what's interesting is that he also lost the ability to imagine color, and he no longer dreamed in color. So here's somebody, well, I don't know how much of the neurophysiology of vision JL knows, but he knows an awful lot about the color of things, but none of that helps him now to experience color, even in imagination. Yeah?
I don't know about the validity of this statement, but I've picked up that since the advent of color TV, more people dream in color.
Yes, That appears to be the case. These kinds of comparisons are always hard to deal with because they're so-called cohort effects. The people who grew up with black and white television it's a different group of people than those who grew up with color television. But there is a study, I can't remember who did it now, I can find this out, or you can Google it when you finish your Facebook page, that in fact, people of my generation, for example, who grew up with black and white television, color didn't come in until the early 60s, are more likely to dream in black and white. In fact, most people dream in color, but there appear to be proportionally more people who dream in black and white. And we don't know what that's all about. There has been certainly no change in the visual system in that period of time, right? It's possible that television, and especially color television, has so warped our imaginations that we now are even more likely to generate dreams in color. Don't really know about that. But that's an interesting question. That is apparently a fact, okay, what you just reported. But exactly why that is the case, I think we don't really know. Yeah, one. You might think that there's a memory stored in other parts of the brain, and what there might be is a memory of the form of trees are green, okay? But apparently V4 is the part of the brain that allows us to construct the experience of green. I don't know of any other cases. There may be such cases. I would think I would have heard about them. These are, Mary and Fred are also interesting, unique cases. These are the only two that I personally know about. One more question, then I got to go on. Yeah, would it be possible to have damage to the optic nerve so you couldn't see something in color, but you could still maybe imagine? Yes, apparently that is possible. Now, don't try this at home, okay? And I don't think there is any such case on record. But when it comes to the sensory modalities, what determines the modality of sensation and what determines the quality of sensation within a modality is not where it comes from, but where it ends up, okay? So that that gives rise to this idea that if you could connect your eyes to your temporal lobe, you'd hear what you see, okay? You got that, right? So now, again, you probably shouldn't try that at home either, but that's the general idea here. So that if a person had an intact V4, they might be able to experience color simply by knowing what colors things are, or they might still be able to imagine things in color even though they couldn't distinguish between the various colors in a colored stimulus. Again, there might be such a case out there. I just don't know of such a case. I suppose you could do this with laboratory animals if you wanted to do that, but not me. I really do have to go on, but go ahead.
When you talked about sensing your eyes,
That is one